Welcome to The Explainer. Today, we're going to pull back the curtain on the magic behind modern AI. From the language models you chat with every day to the AIs that create unbelievable images, it all comes down to one revolutionary idea, the attention mechanism.
Have you ever really stopped and wondered, how does an AI actually get the meaning of a sentence? How does it figure out which words are connected to which, especially when they're not even next to each other? That's a massive, massive challenge.
Well, the answer, the real secret sauce, is this beautifully simple idea that's actually inspired by how we pay attention. It's a mechanism that basically lets an AI model decide which words matter most when it's processing a sentence. And yeah, this is the powerhouse engine inside all those famous transformer models.
All right, so let's get right into it. To really get what attention is, you just need to understand three simple building blocks. They're called the query, the key, and the value.
Okay, first up, the query. The easiest way to think about this is that every single word in a sentence is trying to understand itself, right? The query is basically its search request. It's a little package of numbers, a vector, that it sends out to all the other words, basically asking, hey, to figure out what I mean here, what do I need to know from you guys?
So to answer that query, every word also has something called a key. You can think of the key as like a label or a tag. It's another one of those number vectors, and its job is to broadcast to the entire sentence, here's the kind of information I'm offering. This is what I'm about.
And that brings us to the third piece, the value. This is the good stuff. If a word's key is a really good match for another word's query, the value vector is the actual information that gets sent over. It's the substance, the meaning, the context of that word, all packed up and ready to go.
Okay, and here's a perfect example that makes it all click. Look at this sentence. The animal didn't cross the street because it was too tired. The word it is kind of lost, right? It needs to know what it's referring to. So it sends out its query. Now, both animal and street offer up their keys. The model looks at these and goes, aha, the key from animal is a way better match for the query from it than the one from street is. And boom, it then pulls in the value, the actual meaning, of the word animal. And just like that, it understands. It really is that intuitive.
So, we've got the basic idea down. Now let's peek under the hood at the surprisingly simple math that makes this whole thing work. And don't worry, you don't need a PhD for this. We're just going to look at the recipe, not get bogged down in the calculations.
And there it is, the master formula. This is the scaled dot product attention from that groundbreaking paper, Attention is All You Need. I know, it might look a bit intimidating at first glance, but trust me, it's just a fancy way of writing down that exact same query, key, and value logic we just walked through.
You can actually break this whole thing down into 4 really simple steps. Step 1, we score how similar the words are. Step 2, we scale those scores to keep things stable. Step 3, we use a nifty function called softmax to turn the scores into actual weights. And finally, step 4, we combine those weights with our values. Score, scale, softmax, combine. That's it.
So that first step, scoring, it's literally just matrix multiplication. We take our big matrix of all the queries and multiply it by the matrix of all the P's. And what we get out is this grid of numbers. You can think of it as a lookup table, where each little box tells you exactly how much any given word should pay attention to any other word in the sentence.
Okay, so we have our raw scores. Now comes the scaling step. We just divide all those scores by a specific number. It's a simple trick, but it's super important because it stops the numbers from getting too big, which helps the whole learning process stay nice and stable. After that, we pop those scaled scores into something called the softmax function. Softmax is brilliant. It does 2 things. It makes sure all the scores are positive numbers, and it makes them all add up perfectly to 1. So what we end up with isn't just a bunch of random scores anymore, it's a perfect probability distribution. It's a clean map showing exactly what percentage of attention each word should give to every other word.
All right, theory is great, but let's make this real. We're going to walk through a super small, practical example to see how these numbers actually come to life and how the recipe works step by step.
Okay, so let's pretend our entire sentence is just 3 words long. The AI starts with an input matrix. We can just call it X, where each row is the numerical representation, that vector, for one of our 3 words.
But here's a key detail. The model doesn't just use those raw word vectors. No, it's a bit smarter than that. During training, it learns 3 totally separate special matrices of weights. One for generating queries, one for keys, and one for values. So, it takes our original input, x, multiplies it by these learned weight matrices, and voila. That's how it creates the Q, K, and V matrices we need for the actual attention calculation.
So once we multiply our Q and K matrices together, we get something that looks like this, our score matrix. Let's just focus on that first row for a second. That row shows us the similarity scores from the first word's query against every other word's key, including its own. And, it makes sense that it scores highest with itself, that's the 1.25. But notice it also finds a pretty strong connection to the other two words as well.
From here, it's just following the recipe. Those scores get scaled down, we divide them by that little stabilizing number, the square root of dk. Then they get pushed through the softmax function, which transforms them into our final attention weights. And for the grand finale, we use those weights to create a brand new vector for each word. How? By taking a weighted average of all the value vectors in the sentence.
And this is what you get at the end. That final calculation gives us a brand new vector for our first token. Look at it. The original representation has been totally transformed. It's now packed with rich, weighted context from the entire sentence. It doesn't just represent the word in isolation anymore, it represents the word in its full context. It finally, truly understands its place.
Okay, so we've seen the how, we've seen the mechanics, but now let's zoom out and talk about the why. Why was this simple-looking idea such a massive, earth-shattering breakthrough for AI?
Well, before attention, the dominant models were things like RNNs, and they had a huge limitation. They had to read a sentence one word at a time, sequentially. This created a terrible bottleneck. If two important words were at opposite ends of a long paragraph, the model would basically forget the first one by the time it got to the last. Attention just completely obliterated that problem. It looks at all the words in the sentence at the exact same time. It can instantly draw a direct line between any two words, no matter how far apart they are.
And the advantages are just they're game changers. For one, the model can precisely weigh how important every single word is to every other word. That little scaling factor we talked about, it keeps the training process from blowing up. There's even a clever trick called multi-head attention, which lets the model look for different kinds of relationships all at once, like one head might focus on grammar while another focuses on meaning. But really, the biggest deal of all is that this whole calculation can be done in parallel. And that is what finally made it possible to train the gigantic, powerful AI models that we see everywhere today.
So when you boil it all down, it's this incredibly powerful concept built from just a few simple parts. Ask a question, find the matching key, and grab the value. That's it. A straightforward calculation that completely kick-started the modern AI revolution. And that kind of leaves you wondering, right? If an idea this elegant could get us this far, what simple idea is coming next?